Okay, this podcast we're going to talk about some of the basics of IPv6 connectivity and tools you can use with IPv6. So we'll do that for Windows and Linux. The first thing you want to do is make sure that IPv6 is installed on your machine. One way you can do that is to run the ipconfig command and see if you already have IPv6 addresses. So here in ipconfig, I already have link local IPv6 addresses showing up in my output. Link local addresses are addresses that are automatically configured on every interface. Once IPv6 is enabled, it is only useful on the local link. So that means that if there's another machine plugged into the same switch as this device, then we can use those addresses to communicate, but it's not good outside the local link. So if I was trying to ping Google, for example, I would not be able to ping Google on a link local address. These link local addresses can be thought of like the RFC 1918 addresses, the private addresses that we're used to, except for the fact that these usually don't go off their local LAN. These are only locally significant. So in this case, IPv6 was already installed. If it was not installed, we would go here to our local area connection properties, and it would not be listed here, and we would click install and find IPv6. Depending on what version of Windows you're working with, you may or may not be able to make changes to the addressing within this context. For example, Windows XP did not have this nice little GUI to give out to let you set the IPv6 addresses. So if we wanted to set an IPv6 static address, we'd have to use that with some netsh commands. But Windows 7, I'm assuming Windows 8 has this little GUI we can use to set our DNS settings. So with that being said, let's go ahead and look at our address. Here our link local address for this Windows machine is FE80:454:4185:FECE:5184. Quite a mouthful, right? So probably IPv6, if it ever gets really used, we'll probably be setting up DNS servers all the time so that we don't have to remember these types of addresses. A couple notes about addressing. It is hexadecimal characters, so if there's a G or a Z in there, it's not valid. We have 4 groups of hex characters separated by colons. That would give us IPv6 address is 128 bits long, so that would give us 8 groups if we wrote it out fully, 8 groups of hexadecimal characters separated by colons. We can do zero abbreviation where we can get rid of a group of zeros by substituting it with 2 colons. So in this case, the real address would be, well, let's see, we have 1, 2, 3, 4, 5 groups of numbers, so that means we're missing 3 groups. So the real address would be FE80:00:00:00:454:4185:FECE:5184. So that was 3 groups of zeros that we eliminated by writing with double colons. You may notice this group only has 3 characters. We can also eliminate leading zeros. So if you have a group with 3 characters, then there is a 0 missing at the beginning. So this would really be 0454. And that's about all the abbreviation that we've done on this particular interface. So I have a Linux machine up and plugged into the same switch as this PC. So I'm going to start Wireshark, and then I'm going to capture some IPv6 traffic. So we'll go ahead and capture start, and I'll put a filter for IPv6 and apply it. So there's already some IPv6 traffic going on because all our machines have IPv6 installed in the lab, and it's somewhat chatty. From Windows, depending on what version of Windows you have, Windows XP behaved differently. With Windows XP, you had to ping 6 to specify the address, to specify to Windows that it was IPv6 address, and you also had to specify the interface identifier, which, if we look up here, we have %10, %14, %15. Those are the interface identifiers. So if I wanted to ping an IPv6 address on this interface, I used to have to specify the %10 at the end. Windows 7, they changed the way that works. So Windows 7, you can just specify the IP address. I have written down in front of me the IP address of the Linux machine that I'm connected to. and we will look at that. So let me restart. This is super chatty. Yeah. So let me change this to ipv6. That'll show me less stuff that I don't care about. There we go. So that's less stuff that I don't care about. Let's restart this. Restart. All right, and now I will ping my ipv6 address of my Linux box, and I forgot to take the ping 6 out. So I'll take the ping 6 out, and I'll ping, and it is not working, which tells me I probably wrote down the address wrong or typed it in wrong. So let's look at this. FE807. Oh, that was an A. 7A26. 7A26. So now it's still not working, so I might have possibly wrote it down wrong still yet again. 7826 CBFF FEAC 4708. Well, let's go look directly at the horse's mouth and see what my IP address should be. On Linux, I just SSH into the box. There is on CentOS 6, there is a GUI you can use to look at the IPv6 stuff. Yeah, that was a typo. There is a GUI you can use to look at the IPv6 stuff, but I just SSH'd in, so I'm just going to be using command line stuff. Here's my IPv6 address, and if you look at what I had down here, 7A2B, I had 7A26. So let's try this one more time with the right IP address, 7A2B. Hey, look at that. The ping is now working. So if we look up here, if you recall from your studies of this week's material, we no longer have ARP for IPv6, but we still need the MAC address that goes along with the IP address. So now we use neighbor solicitations. So I captured a neighbor solicitation. The neighbor advertisement is the ARP response. So we look at the neighbor solicitation. Neighbor solicitation. Pretty much, it's the same stuff we had with IPv4 with ARP. Here's the target address I want to have. I need to find the link layer address that goes along with that. So this is my link layer address, so the other side knows who to send the response to if it can't get it from the packet. And here's the target address. And if we look at the neighbor advertisement, this is the ARP reply that came from the other side. So here's a neighbor advertisement. Here's the target IPv6 address, and here's the target link layer address. Let's go ahead and take a minute to look at the IPv6 protocol itself. We have some different things in the IPv6 header that we didn't have in the IPv4 header. The first thing we have is the version, which is still needed. Then we have some traffic class and some flow labels. Those are used to help with performance and quality of service. We can classify the traffic, and then we can give some traffic preferential treatment over other traffic. Payload length, that tells us how long the data is. Next header, IPv6 uses this idea of next headers where it can daisy chain a bunch of headers together to use space more efficiently. By more efficiently, if you recall from the IPv4 header, with IPv4 we always had fragmentation fields in the IP header. We always sent a identification number, an offset, and we had some more fragments and don't fragments bits. So if there's no fragmentation, those bits are essentially wasted. So with IPv6, we have this next header idea, and if for some reason a packet needs to be fragmented, then the next header will be used to indicate that there's a fragmentation header coming. You should have looked at all the different types of headers in the book to see what was available, and that's just a change with the way they do things to make it more efficient. We no longer send bits that mean nothing. Everything is used now, a little more efficient use of our network. Our hop limit in IPv4 we called it the time to live. That was the number of hops that the packet could go through before it was killed. And ICMP error message, the number of hops a packet could go through before it was killed, and an ICMP error message was sent back. Now it's actually correctly named a hop limit. This is the number of hops that the packet can go through. In this case, it's set to 255, the source address and the destination address. And that is it for the IPv6 header. So it says here, it says the next header shows ICMPv6, so that is the application layer that's using this. If there was some other header there, like a fragmentation header or some other header, then that would be listed there. So that's a quick look at an IPv6 packet. So yeah, so we had a neighbor solicitation, a neighbor advertisement, and we were pinging from Windows. To ping from Linux, a little different. Linux, I don't know if CentOS has ping. I don't know if CentOS 6 supports ping to IPv6 addresses without putting the ping 6. I know CentOS 5 did not. So let's see if this works. Unknown host. So ping 6. So ping thinks that is an name, not ping. Ping 6. Invalid argument. When you ping a link local address from Linux, you have to specify which interface you want it to use. In this case, I probably have a typo again, I hope. In this case, I did ping 6-i e13 and then the link local address of my Windows machine, or at least what I thought the link local address of my Windows machine was. If we look up here, the -i, capital I, E13 means send this packet out E13. Let's go see what my IPv6 address is to see if I can type it correctly. FE80 454 4185. Oh, I left off a group of numbers. That's one thing about abbreviating addresses. You can leave off numbers and not really realize it, like I just did. So we go. So now I'm pinging from my Linux machine to my Windows machine at the command line. Ping 6-capital I ETH13. So you need to make sure your ETH number matches up what you're using. If you have multiple interfaces, you need to make sure you choose the right one, and then the IPv6 address. So that is working with link local addresses. If you want to have a static IPv6 address, as I said, on Windows, you can now use the GUI to set it. We will go ahead and set our static address. We'll use FC01:1:2. So most of the time you're going to leave your prefix length at 64. So we spent all this time learning how to subnet IPv4 addresses. We don't really worry about that with IPv6 per se, as far as changing the prefix length to give different size hosts, different size networks and whatnot. So what this means, the first 64 bits are network portion, the last 64 bits are host portion. So in this case, my subnet is going to be FC001:1, and then some more zeros, and then my host portion is going to be a bunch of zeros and then 2. So if I wanted to write this out the whole way, it would really be, well, not really the whole way, because I'm going to be lazy. So is that 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 groups. So if I wanted to write my address out the whole way, it would look something like this. And then 4 groups of zeros. That was 5. So that would be my whole address written out with all the numbers. 8 groups, all the zeros in there. And if I did it that way, it makes it maybe more easy to see. This is the first 64 bits, so that'd be the network portion, and this is the last 64 bits, so that would be the host portion. And then the default gateway, just like IPv4, we need a default gateway to get our packets off our network. So, for example, I could set my default gateway to that if I had a router set up that had that address. Close that. Close. Then you close that. Yeah, so there it shows up that I have my IPv6 address and my IPv6 gateway. So with Linux, you can use ifconfig to add IPv6 address. I don't really feel like reading the man page. I do have a hint sheet in the lab report. Let's see if I have that, the lab document. So hint sheet, Linux, ifconfig, interface, add, and then put the IPv6 address on there. So ifconfig, add, E13, add, FC01:1::. I use 2 for my other PC, so I use 3 for this one, and then a prefix length. So that added that IPv6 address. Like I said, with CentOS 6, you can also do it in the GUI. CentOS 5, the GUI does not support it. We see my IPv6 address shows up, and now I should be able to ping 6 to FC01:1:2. So that is my Windows machine. I should be able to ping now using the real addresses. And it worked. And the question you may be asking yourself is, well, why didn't you have to put the -I13 on there? Well, I didn't have to put the capital I, ETH13, because this is not a link local address. You can only have a interface in real subnets, one interface in each subnet. So it can use the normal routing table to show that. So yeah. So that's it for setting IP addresses, and well, I'll talk about one more thing. We may see this. We'll see this in the lab. I don't know if I'll get a podcast done to show this just yet, but you can also do stateless auto configuration. So your router can send out router advertisements, and if your host is configured for stateless auto configuration, it can use that information the router sends out and generate its own IP address in the particular network. And we'll see that in the lab, and if I get a chance to finish the podcast for the router config, I'll make sure I capture that router solicitation message, router advertisement message, and as well as look at the stateless auto configuration stuff. But just based on this, you now know how to look at IPv6 information on Linux and Windows, and you also know how to set some IPv6 addresses on Linux and Windows.